Let us study Mendeleev's periodic table. Mendeleev developed his periodic table in the year 1869 to 1872. During his time, there were 63 elements. Scientists discovered 63 elements. He arranged the elements in the increasing order of their atomic masses. He made his own periodic table as well as he arranged the elements in the vertical columns as well as in the horizontal. This is vertical columns we can say. Such arrangements, this is known as horizontal rows. He arranged the elements in the vertical columns as well as horizontal rows. In his time, total 63 elements were there, even though he left many places for arranging the elements which will be discovered later. He made a law. That law is known as Mendeleev's periodic law. Now, what is Mendeleev's periodic law? Mendeleev's periodic law states that the properties of the elements are the periodic function of their atomic masses. What is Mendeleev's periodic law? Mendeleev's periodic law states that the properties of elements are the periodic function of their atomic masses. He arranged the elements in the increasing order of their atomic masses. Now we will study the merits of Mendeleev's periodic table. First merit of Mendeleev's periodic table is he revised means he changed the atomic masses of, revised means changed, the atomic masses of some elements in his periodic table for arranging them properly in his periodic table. For that, one example we are going to study, that is beryllium. Its atomic number changed from 14.09 to 9.4 for putting beryllium properly in his periodic table. Now we are studying about the second merit of Mendeleev's periodic table. He left many places in his periodic table for the undiscovered elements. Here some vacant places, he put some places, some atomic masses, but he left the place without naming them. In his periodic table, he predicted the names of 3 elements. They are Eka, boron, Eka, aluminium, and Eka, silicon. In his periodic table, he predicted the names of 3 undiscovered elements. They are Eka boron, Eka aluminium, and Eka silicon. And he predicted their characteristics, even their atomic masses. Eka boron, its atomic mass is 44, Eka aluminium 68, and Eka silicon, its atomic mass 72. These all things he already predicted before discovering them. Later, after discovering, he changed the names of these elements as scandium, gallium, and germanium. So after discovery, these names changed to this name, that is scandium, gallium and germanium. What all characteristics, physical character, chemical character as well as their nature, which all things he explained about all these elements before discovery. After discovery, they just matched and seen. So they found that all the characters of these three elements which he had predicted, everything was matching well. As a result of it, he became very popular. So we can say that here he left many places in his periodic table for the undiscovered elements. He predicted three elements in his periodic table and named them as Eka boron, Eka aluminium and Eka silicon. Later, after discovery, he given the name to them as scandium, gallium and germanium. Even he predicted their atomic masses before their discovery, that is 44, 68 and 72. Which all characteristics he predicted to the undiscovered elements, everything found same after discovering them. Now we are studying about the third merit of Mendeleev's periodic table. He didn't leave any place for noble gases. Even though after, are you knowing about the noble gases? Noble gases are helium, neon, argon, krypton, xenon and radon. These are noble gases. When he made or when he developed his periodic table, there was no provision for arranging these noble gases. Later on, once they discovered these noble gases, he made a separate group. That separate group is known as zero group. And he fitted them in the periodic table without disturbing the periodic table. That means the periodic table what he had made, it's one side he fitted the zero group elements. As a result of it, there didn't occur any disturbance to the periodic table. So we people studied now three merits of Mendeleev's periodic table. The first one, he changed or he revised the atomic masses of the elements. For example, beryllium's atomic mass changed from 14.09 to 9.4. Second thing, he left many places in his periodic table for the undiscovered elements. Middle, he given some undiscovered elements atomic masses, but for the name he left the places. Three places he given the name to the undiscovered elements. Later, after discovery, they all shown same character which he had predicted before. Before discovering, he given the name to the undiscovered elements as Eka boron, Eka aluminium and Eka silicon. But after discovery, he given the name to the Eka boron as scandium, Eka aluminium as gallium and Eka silicon as germanium. Even he predicted their atomic masses. Eka boron atomic mass 44, Eka aluminium atomic mass 68 and Eka silicon atomic weight 72. Atomic weight or atomic mass same. Later, he didn't leave any space for arranging zero group elements. Even though after discovery, he created a new group in his periodic table that is known as zero group elements. They are helium, neon, argon, krypton, xenon and radon. You can see the periodic table, large periodic table, it's one side. He fitted these zero group elements without disturbing his own periodic table what he had made before. Now we are going to study about the demerits of Mendeleev's periodic table. Now what is the demerits of, or here again we are going to study 4. Now 3 merits of Mendeleev's periodic table we studied. Now we are going to study about demerits of Mendeleev's periodic table. There are 4 demerits of Mendeleev's periodic table. Demerits means what? Disadvantages, or we can say the limitations of Mendeleev's periodic table. The first demerit of Mendeleev's periodic table is the atomic masses of cobalt as well as nickel was same. There he faced a lot of problem. That means there occurred so much confusion in arranging cobalt as well as nickel in his periodic table. Now if you are seeing cobalt, its atomic mass is 59. Again if you are seeing nickel, its also atomic mass is 59. Both of the elements are having atomic mass 59. He arranged the elements in the increasing order of their atomic masses. But here both of them are having same atomic mass. Because of that, there occurred a confusion for arranging these elements in his periodic table. Second point, we are speaking about isotopes. Now, what are isotopes? Isotopes are present in each and every element. Suppose we are studying about oxygen. Oxygen, its symbol is O. It has many isotopes. Isotopes means they are the atoms of different elements. Now few examples of isotopes of oxygen I am writing. Oxygen, here its atomic number will be same. Here again other I am writing, atomic number will be same. Here other oxygen I am writing, atomic number will be same. But their mass number, one is having 16, other one is having 17, other one is having 18. So we can say that the element oxygen has different isotopes. Speciality, different atoms are there. All are oxygen atoms only. Even then, their mass number, that means atomic mass is different, atomic number is same. Now if you are studying about other element, that is chlorine if you are taking. Chlorine has many isotopes but a few names, 3 names I am writing. Here we can say its atomic number 35, 35, 35. But mass number, one place 35, other place 36, other place 37. So here what I am saying you, atomic number is same but their mass number is different. Here what is there? Oxygen when we study, atomic number same but mass number different. Now one more example I am saying, that is about hydrogen. Hydrogen is also 3 isotopes name I am writing. All are having same atomic number but mass number, first one 1, second one 2, third one 3. So here what is saying, when we look all are oxygen, when we look here all are chlorine, when we look here all are hydrogen. But problem what is there, all are having different mass number, here all are having different mass number, here all are having different mass number. Because of that, arranging these isotopes, Mendeleev didn't leave any space in his periodic table. Why? Because he arranged the elements in the increasing order of their atomic masses. So here all isotopes are having different atomic masses. So there should have place for them, but Mendeleev didn't think about the isotopes. Then these isotopes discovered long time after Mendeleev. Now we are going to, so first point we had studied. What is the first point? The whole atomic mass of cobalt as well as nickel same. As a result of it, for arranging or for giving place to these elements, there so much confusion occurred in his periodic table, where we should or where he has to arrange them. So much confusion arised in the minds of or in the mind of Mendeleev. Second thing, during his time there was no isotopes. Later, after long time, after his time, they discovered isotopes. Isotopes are atoms of different elements. For these elements' speciality, all are having different, these isotopes' speciality, they are having different atomic mass number but same atomic number. So, for arranging these isotopes, Mendeleev didn't keep any space. So, we can say that this is again a disadvantage or demerit of Mendeleev's periodic table. Now, the third point, that is the rise in the atomic mass number in his periodic table. Now, he arranged the elements in the increasing the atomic mass number. Increasing order of their atomic mass number only, he arranged the elements. But problem what is there? Suppose here hydrogen is there. Then other element I am writing here helium is there. Suppose. Then other element here sodium, here lithium he written. Like that way beryllium, like that way different elements he written. Just imagine. So what should be there? Here difference in their atomic mass number was not uniform. Here suppose atomic is mass number 1. Then here atomic mass number 2. Here atomic mass number 3, 4, 5. Like that if it is there, we can say that mass number, he arranged the elements in the increasing order of their atomic mass. At the same time, the difference between two elements, that is uniform. But when he arranged the elements in his periodic table, the difference in their atomic mass was not uniform. Because of that, again they faced the problem in between two heavy elements, how many elements need to discover? That was a question mark. Why? Because there was no uniform difference in their atomic mass number when he fitted the elements in his periodic table. Now, last point children, that is there was a confusion for putting hydrogen in the periodic table. Which periodic table? Mendeleev's periodic table. What was the doubt? Hydrogen either should be along with the alkali metals or with the halogens. That was the question. Hydrogen either should be with the alkali metals or with the halogens. Now, which are alkali metals? Lithium, sodium, potassium, rubidium, cesium, etc. So, here halogens which are fluorine, chlorine, bromine, iodine, etc. Now, this hydrogen is having similarity in the character with alkali metals as well as with the halogens. Now we can say that if we are thinking of the relation of hydrogen with the alkali metals, now these alkalis are having the capacity to react with chlorine as well as they are having the capacity to react with oxygen. So, these hydrogen having the capacity what? Hydrogen is showing similarity with the alkali metals. Now, alkali metals are having the capacity to form their molecular formulae with the chlorine as well as with the oxygen. Same way, even hydrogen is having the capacity to react with chlorine as well as, or we can say here with the halogens we can say. Chlorine alone, not even with the halogens it can react, even here with the oxygen. So first example I written lithium chloride as well as lithium oxide. Similarly, sodium chloride and sodium oxide. Same way, all other elements also having same property for forming molecular compounds with oxygen as well as chlorine. Now similarly, hydrogen also having the capacity to react with halogens as well as oxygen to form its compound. We can say molecular compound. Here lithium chloride, sodium chloride, hydrogen chloride, all are alike. Means look-wise combination, the compound formation is same to same. Here now with the oxygen, the compound formation with lithium, with sodium, with hydrogen same. So we can say that hydrogen shows same character like alkali metals. Now when we are studying about or when we are thinking about halogen, hydrogen is showing the capacity in the formation of molecular formulae. Let us see now. Hydrogen H2, fluorine F2, chlorine Cl2, bromine Br2. So same way, molecular formulae of hydrogen is having similarity with the halogens. Hydrogen has similarity in the formation of molecular compounds with the alkali metals. So here confusion arised in the mind of Mendeleev where to put hydrogen, either with the alkali metals or with the halogens. So here now we had studied 4 disadvantages or demerits of Mendeleev's periodic table. The first one, what was there? First one, he arranged the elements in the increasing order of their atomic masses, but at whole atomic mass of cobalt as well as nickel was same. So there occurred a confusion in the mind of Mendeleev for arranging cobalt as well as nickel. That means which element will put first, which element will put next. Why? Cobalt as well as nickel having same to same atomic mass number, that is 59. Second thing, isotopes which discovered after him, for arranging in his periodic table, he didn't leave any space. I had already shown you isotopes of different elements, that is oxygen, it has 3, many isotopes are there, but 3 examples I shown, that is oxygen 16, oxygen 17, oxygen 18, chlorine I shown 3 isotopes, that is 35, 36, 37, many are there but few examples I shown. Hydrogen 1, 2, 3, their atomic masses are different but their atomic number is same, but he arranged the elements in the increasing order of their atomic mass. So he faced, or so the scientists faced, lot of problem for arranging the isotopes in his periodic table. Then next one, we are studying about rise in the atomic mass of the elements. When he arranged or when he made his periodic table, there he arranged the elements in the increasing order of their atomic masses. But problem occurred between each and every element. There was no uniformity in the increasing or in the atomic mass number of all the elements. Now we can say that now oxygen, suppose oxygen is there. Afterwards here other element, that is now chlorine is there. Just imagine. So here atomic mass number of oxygen is 16. Then other element should be 17, or if it is 17. Again next element, now I am writing here argon 18. So we can say that in between two elements, one difference only is there. This I written as modern periodic table, but in his time he didn't arrange such a way. One element, suppose, now one element I am writing potassium. Its actual atomic mass is 39.1, but I am writing here now 25, just an example. Then other element he is writing, suppose argon. He is writing, means maybe some different in value. That means suppose we can write 36. These are not correct values, wrong values. Now other one I am writing here now sodium, suppose. Now its value I am writing here as 48. So you just see the difference. It is not the correct answer, wrong answer, but just for showing you the example. In his periodic table, the difference between two elements atomic mass, here how much will be there? 11 difference I am saying you now. 11 difference. Here the difference how much will be there? 12 difference. Like that way means uniform difference was not there. Because of that, scientists faced a lot of problem for finding the new elements. How many elements we have to find out? Such a confusion occurred in the minds of other scientists. Now, last last demerits of Mendeleev's periodic table, that is, he faced lot of problem for arranging hydrogen. Hydrogen was showing the properties similar as alkali metals as well as halogens. Alkali metals example I written here few: lithium, sodium, potassium. Here halogens example I written few, that is fluorine, chlorine, bromine. Now lithium is having the lithium, or these alkali metals are having the capacity to react with chlorine as well as oxygen, and we can say that their own molecular compound they are able to form. Same as these alkali metals, even hydrogen having the capacity to react with the chlorine, and hydrogen chloride can form. It can react with the oxygen and it can form its own oxide, that is water. Now lithium can react with oxygen, lithium oxide. Sodium can react with oxygen, sodium oxide. Hydrogen can react with oxygen, hydrogen oxide, or we can say that water forming. Lithium is having the capacity to react with the chlorine, lithium chloride. Sodium, sodium chloride. Even hydrogen is having same character as them. Because of that, hydrogen shows similarity with the alkali metals. Now, when we consider here, hydrogen is having the capacity to show the same character as halogens. We can say hydrogen is having the capacity to form hydrogen molecule. Same way, H2 molecule we can say. Now fluorine, F2 molecule. Then chlorine, Cl2 molecule. Br, that is bromine, Br2 molecule. So molecular form or molecular formulae of hydrogen, fluorine, chlorine, bromine, all halogens are same. Because of that, Mendeleev faced lot of problem for fixing the position of hydrogen in the periodic table. Thank you.